students. I welcome you to another exciting chemistry class. Let me ask, how is it going with you, with your experience of chemistry so far? I believe that you are finding it enjoyable. Welcome you to Eko Learners Support for WAEC and NECO candidates. This program is designed to help you to be able to improve in your studies. Today's class is going to be very interesting, and I want to probe your mind so that you can actually be the one that will tell me what we will be discussing today. Now, let me give you some useful tips. Have you ever seen two people come together to start a business? Have you ever seen two people come together to start a marriage? Have you ever seen two strangers come together and become friends? What do you think today's topic is talking about? You're very correct. Today, we will be learning about bonding, chemical bonding. Are you ready? Come on, let's dive right in.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
So, I want you to take your notes and your pen, write the topic down. This is the first part of this topic, Chemical Bonding 1. And in this class, we will focus on two types of bonds, ionic and covalent bonds. We've set these learning objectives to guide us. At the end of this lesson, you should be able to identify the different ways an element bond. 2, you should be able to compare and contrast ionic and covalent bonds. And lastly, you should be able to apply the knowledge that you have acquired from this class to solve relevant past questions paper. What are some keywords that will be useful in understanding this topic? Bond. Yes, bond. You heard about James Bond. That's wonderful actor. Yes. So bond has to do with something that brings two people together. Stability has to do with having, an equilibrium, a balance. The third one is electrovalent. Yes, electrovalent means that electrons are involved from the word electron, electrovalent. Covalent. Covalent is the opposite. Electrovalent has to do with transfer of electron. Covalent has to do with what? Sharing of electron. Co, like a partner. So, I want you to take this brain teaser to prepare your mind for what we are going to learn today. And I'm giving you 1 minute to figure out which cup is going to get filled first. Yes, please go ahead. Look at the connectors in all the cups. This is actually teaching you how to be detailed and pay attention to every single thing that matters. So what do you think? Is it cup 1 or cup 2 or cup 3 or cup 4? What do you think? All right, let's look at it together. If you look at cup 1, okay, there's no pathway. This is blocked, so no tea is going to flow in there. Let's look at cup 2. Yes, the tea flows there, but wow, The tap is closed, so no tea is going to flow into cup 2. How about cup 3? Let's look. Yes, the tea goes in there, overflows, and then comes here. This is open. Let's look at cup 4 and be sure. Okay, wow, there's a closure there. So the cup 3 is the only cup that is going to get filled. I hope this has actually prepared you and you are in a learning mode right now. Well done to you. This is an inspirational quote given by the world-renowned Mother Teresa. And she said, "I can do things you cannot. You can do things I cannot. Together, we can do great things together." And this is the spirit about coming together, about collaboration. That's your periodic table. Now, let's introduce the topic properly. What is a chemical bond? Before we discuss what a chemical bond is, I want you to look at all the different types of bonds that people form. For example, you can see a collaborative bond among students in a chemistry lab. They're working together there. They're sharing ideas, okay? Friendship bond, okay, where a gift is exchanged between two friends, maybe on a birthday. You have marriage bond between a husband and a wife. And we talk about chemical bond. So a chemical bond is a lasting attraction, okay, between atoms, ions, or molecules that enable them to form compounds. The emphasis here is on lasting attraction. In real life, we have different types of bonds that people share among themselves. Now that you have learned what a bond is, now, why do atoms need to bond? What is the need for bonding? You may ask. Now, if you look at the periodic table, you will see that a particular family of elements, which we call the noble gases, they usually have a completely filled configuration. So, in my mind, these are the only elements that are happy naturally because they have everything other atoms are looking for. And those elements include helium, neon, argon, krypton, xenon, radon. They are chemically stable, and that's why they are unreactive. But for other atoms, they will have to make effort for them to achieve stability. If you look at the picture here, the noble gases are telling the other atoms, no, we are completely filled. And this atom cannot join the cruise because there is no space. So still on why do atoms combine? Unlike the noble gases that have completely filled valence shells, other atoms have to enter into chemical bonding with other atoms in order to be stable. So to answer that question straight up, why atoms bond together is to achieve stability. The reason for chemical bonding is to achieve stability. You can see the couple there. The wife is saying, oh, you make me feel like a noble gas. And the husband is saying, oh, you make my valence shell complete. They are saying the same thing. Both of them are happy. What are the different types of chemical bonding? We want to look at how atoms play. How do they roll? How do they cruise? How do they come together? Now, we classify them into two. We have the intramolecular bonds and we have the intermolecular. The word intra means within. The word inter means without, outside. Okay? So, among the intramoleculars, we have the ionic, the covalent, and the coordinate covalent. While among the intermolecular, we have the hydrogen bond, the London forces, the dipole-dipole attraction, and of course, the van der Waals forces of attraction. Like I said, this class is going to focus only on ionic and covalent bonds. In subsequent class, we will look at the other types of bonds. Now, let's switch gear to electrovalent, or what we call ionic bonding. Another name for ionic bond is electrovalent. And you can see there a husband or a fiancé proposing, okay, on his bendel nails, okay. One atom will have to lose electrons. So the atom that loses the electron is actually the metal. And we're talking about elements with 1, 2, or 3 valence electrons. These are metals, and they will be the one to lose electrons. Then the non-metals, because electrovalent bonding takes place between a metal and a non-metal. Then the non-metal usually gains the electron. And how do you identify them? They usually have 5, 6, or 7 valence electrons. The name is bond, and I am ionic bond. Okay? Telling you there that it is taken, not shared. Because in ionic bonding, we talk about complete transfer. It is not about electron sharing. It is winner takes all. Now, let's look at some example. Electrovalent bond is an electrostatic force that exists between particles of opposite charge that result from a transfer. That's the key word there. Complete transfer of electrons from one atom, which is usually the metal, to another, which is the non-metal. Now, let's look at an example of electrovalent bonding. Now, what we have here, we have sodium atom. We have sodium atom with atomic number 11. If we share that electron, we are going to have 281. Now, the other atom is chlorine, atomic number 17. You now know why you need to have your periodic table, or even to be able to memorize the first 20 elements. Now, when you share those 17 electrons, that will give you 287. Now, I ask you, between the sodium and the chlorine, which is the metal, which is the non-metal? Fantastic. You're correct. The sodium is the metal because it has 1 valence electron. Metals usually have 1 or 2 or 3 valence electron. By valence electron, we mean the number of electrons on the outermost shell. Chlorine has 7. So what is going to happen is a complete transfer. The sodium is going to transfer this 1 electron, okay, to the chlorine. So the sodium is an electron donor, while the chlorine atom is an electron acceptor. Now, magic happens when we sacrifice. And that's exactly what happens here, because the sodium has lost 1 of its electrons. It's now going to become a sodium ion with a plus sign. When you give, you are blessed. And that's why sodium is blessed there. And it will now have a new configuration of 28. Yes, that's exactly what happens. Sodium has now have a configuration of the noble gases just by giving it valence electrons. Now the chlorine is going to also become an ion, which we refer to as chloride ion. And its own configuration is now going to be 2, 8, and 8. You can see just by going into bonding, the sodium is now happy and the chlorine is also now happy. And because ions are formed, sodium ion and chloride ion, this type of bonding is referred to as ionic. Yes, that's where it got its name from, ionic, because it results into formation of aggregate of ions. I hope that you are able to get what happens during electrovalent bonding. What are some characteristics of electrovalent compounds? A compound that is formed as a result of electrovalent bonding is referred to as electrovalent compound, or simply an ionic compound. They have some characteristics like the fact that they are usually crystalline solids. Yes, they are usually crystalline solids. If you look at your sodium chloride, you will see that they are cut into shape. That's what we refer to as crystalline solid. 2, they usually have high boiling and melting point. Because of the strong electrostatic force of attraction between them, it requires a lot of energy to break them down. And so the boiling point and the melting point of covalent, electrovalent compounds, I beg your pardon, are usually high. Another characteristic, I hope you are documenting this down, is that ionic compounds are usually soluble in water. Why? Because they are polar solutes. They are polar compounds. Polar there means that they have ions. And because water also contains ions, so there is interaction. So that's why your salt at home can dissolve in water. We call it the principle of like dissolves like. A polar solute will be dissolved by a polar solvent. I mentioned 3 characteristics now. 4 is that ionic compounds are good electrolytes. That means they conduct electricity. But there's a caveat there. They do not conduct electricity in the solid state. Rather, when they are dissolved in water, which we call aqueous solution, or when they are melted, which we refer to as molten. So these are the 2 states in which the ionic compounds conduct electricity, in molten state or in aqueous solution, but not in the solid state. And why is that? It's because in the solid state, yes, the ions are present, but the ions are unable to move. And when there is no movement, my dear, there is no electricity. So these are some characteristics of ionic compounds. Let's move and look at the other type of bonding. So let's look at covalent bonding. Unlike ionic bonding that involves complete transfer, a kind of sacrifice between a metal to a non-metal, covalent compounds are usually 2 non-metals. So what happens there is that they share electrons. That is very, very germane point that you have to take note of. In covalent compounds, we talk about what? Sharing. Like we commonly say, there is love in sharing. That's what covalent compounds do. They share electrons. The bonds that form between the non-metals only. So this bond is usually between non-metals, and they produce molecules. Unlike ionic compounds that produces ion, covalent compounds produce what? Molecules. And an example there is hydrogen. If you look at the hydrogen diagram that you have here, so hydrogen has 1 electron. Let me pick my pen. So hydrogen has 1 electron, and that is a 1 electron. So the first shell is the K shell, so it's going to 2. So it needs to come, invite another hydrogen, and both of them can come together, and you can see the bond that they share. This type of bond between them is what we refer to as what? Covalent bond. Covalent bond. And you can see all different shades of covalent bonding. You can see the 2 siblings there playing. Now you can see this other one sharing their meal. And you can see this other one. Now, it is nice to share, but the question is it always equal? When we share, is it always equal? Yes, sometimes it is equal, like what we have in this diagram, but sometimes it is not equal. Like you can see the older sibling denying the younger one of the ice cream there. So what happens if the sharing is not equal? Now that results into this. So we have non-polar covalent when there is equal sharing. That is mutual. But when the sharing is unequal, that results into what we call polar covalent, which we are going to discuss, especially when we get to hydrogen bond. So how do you know who wanted it more? Okay, that would depend on the what? The electronegativity of each atom. And that will tell us who is able to pull the electron more toward itself. So, covalent compounds or covalent bonds is not usually single. Yes, most times, like you saw in the hydrogen, it can be single bond, but sometimes Sharing single bond is not enough for the two atoms to achieve stability. So they have to share more, and that's why we have what we call double bond. For example, in the case of what? Oxygen here. Two oxygen atoms here are coming together. And because one oxygen atom, okay, has 6 valence electrons. Oxygen is atomic number 8. So you have 6 valence electrons. That's 1, 2, okay, 3, 4, 5, and 6. Then there's the other oxygen atom, 1, or let me represent its own electron with a star using the Lewis structure. Okay, so I'm representing this other oxygen electron with a star. That's 1, 2, 3, 4, 5, and 6. So they can share this bond. By the time they share this bond, you will see that it's not enough, because that means for this oxygen, you now have 1, 2, 3, 4, 5, 6, 7. It's not enough, so they have to share more. And that forms what? A double bond. For other, like the nitrogen molecule, they even form triple bond. If you look at a nitrogen atom, it has 5 valence electrons. Okay? So it comes together with another nitrogen atom with 5 electrons. So you can share this, and share this. If you count the number of bonds surrounding each atom now, you will see that it is now 8. This is 2, 4, 6, and 8 for this nitrogen. 2, 4, 6, and 8 for this other nitrogen. That way, everybody is stable and happy. Let's now look at our top exam-styled question. I hope you're ready. Now, the first question says, what is a covalent compound? You have to be careful here in the exam. There's a difference between a question asking you what is covalent bonding and a question asking you what is a covalent compound. Now, if the question asks you what is covalent bonding, you say it is a type of bonding that involves, okay, sharing of electrons between two non-metals. Are you with me? But if the question asks you what is a covalent compound, you will be saying that a covalent compound is a compound, okay, that was formed by sharing of electrons. It's just being smart, okay? So you just need to tweak the definition to suit the concept that you are defining. So a covalent compound is one that is formed by sharing of electrons between two or more atoms, and they are all molecules. One very good characteristic of covalent compound is that what? They are molecules. The next question is asking us for 3 characteristics of covalent compounds. Unlike ionic compounds that have high melting and boiling point, covalent compounds have low melting and boiling point. This is because the force of attraction between them is relatively weak. 2, covalent compounds are not usually soluble in water. Instead, they are soluble in organic solvent, like carbon tetrachloride, okay? Another characteristic is that covalent compounds are molecules. They do not contain ions, but they are molecules. Another one is that they are usually, okay, gases. Many of them are gases. Talk about what, we talk about ammonia, we talk about carbon dioxide. Many of them are gases, or sometimes they are volatile liquids. They are rarely solids, unlike the ionic compounds that are mainly crystalline solids. Another characteristic is that covalent compounds do not conduct electricity. And if I may ask, why? Yes, exactly what you said. Because they do not contain ions. Ions are necessary for electricity to be conducted. That's wonderful. Please give yourself some cheers. Let's look at the third question. State the type of bond that is present in the following. The first one is ammonia. Ammonia, what type of bond do you have in ammonia? So, if you have a question like this in the exam hall, the first question you must ask yourself is, what are the type of elements that are present in ammonia? Ammonia is NH3. That is the formula. So if you look at the composition of a compound, you will be able to know the type of bond that is holding the atoms together. Yes, just by knowing the atoms that are present there. So if you look at nitrogen here, is it a metal? No, it's not a metal. It's a non-metal, okay? You look at hydrogen, it's another non-metal. So when you have two non-metals coming together, definitely this is what? A covalent compound. The bond here is covalent bond. Because the question is asking us about what? The type of bonds. How about aluminum oxide? Do you think it's covalent? No, you don't. Of course, I expect you to be able to figure that out. Why? Because the formula of aluminum oxide is Al2O3. And what are the atoms that are present here? Aluminum, is it a metal? Yes, of course, that is what you have in your soft drink, okay? The can, aluminum. Oxygen, is it a metal? The answer is no, it is a non-metal. So this bond is between a metal and a non-metal. That makes the bond to be either you refer to it as electrovalent or ionic bond. Electrovalent or ionic bond. Wow, you made it. And I hope that you have learned a whole lot in today's class. Don't worry, we have a lot more bonds to cover in subsequent lessons. But you need to really sit down and understand these elementary before we move to other bonds. I'm very, very delighted to have been able to do this with you.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
If you have any feedback, please do not hesitate to use the link that is displayed on the screen and tell us what you feel. I'll see you next class. Keep learning and keep enjoying. Bye.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.